In this video, we're going to discuss graphing a linear equation that is in slope-intercept form. Before we talk about graphing, perhaps we should just review briefly what slope-intercept form is. Slope-intercept form is just a special kind of equation. In this case, you can see the format of it is y equals mx plus b. I guess the first thing we could say is the m and the b, they could be positive integers, they could be negative integers, they can be fractions, they can be decimals. You could have just the mx without the b. You can have just the b without the mx. Lots of variations on the basic equation form. But again, it's y equals mx plus b is the standard, is the slope-intercept form. One thing to remember about these equations is that these are linear equations, meaning the graph of them is a straight line. You'll never see any curves in graphs of equations that are in slope-intercept form. The b component of the equation is called the y-intercept, and it simply tells us where the line is going to cross the y-axis. It doesn't tell us anything about the line, which way it's pointing, or anything like that. All it tells us is that this line is going to cross the y-axis at this point. The m component of the equation refers to the slope of the line, and it tells us how steep the line is and which way it leans, if any. For example, a line that goes from a lower left to upper right has positive slope. A line that runs downhill from left to right has negative slope. A horizontal line has zero slope, and a vertical line has undefined slope. We'll talk more about the names of each of these slopes and how they came to be in another video. Okay, let's try to graph a linear equation. Let's graph the linear equation y equals 3x plus 1. We'll start by using the y-intercept value in the equation to find the first point of the graph. And remember, the y-intercept is simply the point where this line is going to cross the y-axis. In this case, it's positive 1 plus 1. That means the line crosses the y-axis at the point 0, 1. Next, we'll use the slope to identify the second point on the line. In this case, the slope is 3. Now, since the slope is always a fraction, remember, it's the change in y divided by the change in x as you move from one point to another. Many of you probably also know it as rise over run. We'll put a 1 under the 3 to make it a fraction. Hopefully, you'll also remember that if you take an integer and divide it by 1, it has no impact on the value of the integer. So we're not changing the equation in any way by doing this. The 3 over 1, and remember the 3 over 1 is the rise over the run. It means we'll start at the first point, and we'll go up 3 units, and then we'll go to the right 1 unit. That'll put the second point at the coordinates 1, 4. Now all we have to do is connect the 2 points, and we're done. Okay, let's do another example. This time let's do y equals negative 2/3 x plus 4. We'll follow the same process as the first example. So step 1, we're going to use the y-intercept to identify the first point on the line. That puts the coordinates of the first point at 0, 4. Step 2, we'll use the slope to navigate to the second point from the first point. Starting at the first point, we'll go down 2. We go down this time because the 2 is negative. So we're down 2, and we go to the right 3. That puts the second point at the coordinates 3, 2. Lastly, step 3, we connect the points, and we're done. Okay, now it's your turn. Try to graph each of these linear equations. Y equals 4x minus 1, y equals negative 1/2 x plus 3, y equals negative 2x minus 3, and y equals x. Pause the video while you work on those, and then when you're finished, I'll show you the answers. Here's the graph for the first one, y equals 4x minus 1. The minus 1 tells us that this line is going to cross the y-axis at negative 1. So the coordinates of the first point are 0, negative 1. The slope is 4, which will make 4 over 1. 4 tells us we'll go up 4 units. We'll go 1 to the right, and the second point will be at 1, 3. We connect those 2 points, and we got it. Number 2, y equals negative 1/2 x plus 3. The plus 3 tells us that the line's going to cross the y-axis at 3, at the coordinate 0, 3. And the slope is negative 1/2 x. The negative 1 means we go down 1 this time because it's negative. We go to the right 2. That puts the second point at 2, 2, and we connect the 2 points. Number 3, y equals negative 2x minus 3. The negative 3 tells us that the line's going to cross the y-axis at negative 3. The coordinates of that point are 0, negative 3. The slope is negative 2x. We'll make the negative 2 negative 2 over 1. The negative is telling us we need to go down 2 this time, so we'll go down 2. We'll go 1 to the right. That's the second point on the line. The coordinates of that are 1, negative 5, and we just connect the 2 points. Last one, y equals x. In this case, you see we don't have the b component. We don't have the y-intercept, so we're going to assume that it's 0. What that tells us then is that this line is going to cross the y-axis at the origin at 0, 0. The x has a 1 implied in front of it. We just don't write it whenever it's just 1x. So that means the slope is 1 over 1, which means we'll start at the origin. We'll go up 1, over 1 to the right, and the second point is going to be at 1, 1. We connect the 2 points, and we got the line. Done.